Welcome everybody to our monthly Collab Days essay webinar. So today we have Keith Atherton joining us all the way from the UK. I guess he'll give us more details about himself. But yeah, feel free to put any questions that you have in the Q&A section. Otherwise, you can ask Keith questions after he has presented his webinar. But over to you, Keith.
Yeah, thank you so much. Thanks everyone for joining us today. Appreciate you spending your time with us. So, yep, I'm going to do a session here for Power App Optimization. And just, yeah, as mentioned there, if there's any questions, we'll have some time at the end. Or if you think of something later on, or you'd rather ask after the session, just connect with me on LinkedIn. So let's start here. Just a bit about me. My name is Keith Atherton. I'm a Power Platform architect. My background is as a professional developer. I've got about 25 years as a coder. Just in the last few years, 3 to 4 years, doubling down on the Power Platform. So I'm also a Microsoft MVP and certified trainer as well. So again, anyone's got any questions, just search for me on LinkedIn and connect with me there. So what we're going to look at today, we're going to look at a few different topics. So we're going to look at code optimization. That's going to be the bulk of today's session. Architectural optimization, some kind of high level questions we might want to ask, user experience or UX considerations, and then some monitoring and troubleshooting tips as well. So just a little heads up, I'm probably going to go at a decent pace here because there are a lot of tips that I want to share, and I'd rather share as many as possible because some of them you might know already and some of them might be new. So I don't want to just spend time on covering only 2 or 3 because there might be things that you already know. So anyway, let's make a start. So why would we want to optimize? Now, really, some of the things we want to think about by making something faster is that we want to improve that user experience and ideally improve the user satisfaction. And key for many of us here in our organizations or the customers we deal with is to drive user adoption. So we want people to enjoy using these apps and experiences so much that they might actually become a champion of them or advocate to others, hey, you got to check this out. It works really well. It's really fast. There are sometimes as well occasions on projects, very rare for me, but there might be a non-functional requirement or an NFR for that project, which might specify that you've got to meet certain times that the app has to load within 3 seconds, or that a new page in the app must load within 1 second, for example. So for me, that's quite rare. Only when I've been working as a game developer, we've aimed for certain frame rates and things like that. But typically most projects don't, but it's something just to be aware of. You might need these tips to actually meet a requirement on a project. So one of the examples there where it might be measured is things known as performance models. I won't go on too much detail onto this. I want to get into the tips, but there's one known out there called the Rail performance model developed by the Google Chrome team. And this is a really good example where Rail stands for response, animation, idle, and load. And again, they've measured these metrics, say we want animation to run at 60 frames per second or faster, because any less, it might be a bit laggy and it gives a poor experience. So again, they've done their studies, they've done the research and come to those conclusions why it should take as long as it should. So what we're going to look at first is code optimization. This, again, to be the bulk of what we cover today, and then some other sections afterwards. So many of us here might be familiar in Canvas apps with the app object, and they've got a property called onStart. So in the top right hand side, we've got an example, a screenshot there of the onStart object where we set a global variable called x to a value of 1. So in this example, it's not doing very much, but I have seen some apps and I've developed some apps where I've gone to pages and pages of code on the app onStart for all the work and all the data pulling it does at the very start. And this can affect the loading time of the app as well. If it's going to do too much work, it might take a long time to load, maybe 5, maybe 10, maybe 20 seconds. I saw one recently, it took a minute to load. And there might be users that think it's crashed, it's broke, it's not good, or it's a poor experience. If it's taking a long time to load, maybe the app would run slow as well. It can give people a bit of a bad impression. So what we're going to look at is some alternatives that we've got that can actually improve this experience. So in this example, I've got an app here, and this is the first screen that we're showing. I'm going to go to the app onStart object. And then if I go up here, I'm going to just zoom in on this because it's a bit small on the screen. But on the app on start object, I'm doing this block that I've highlighted right here. It's called meaningless slow code because it doesn't really do anything useful. It just does a really big loop of 50,000 records and comes up with lots and lots of random numbers. So again, it's not moving data or doing anything useful. I just wanted to run some code that would take a few seconds to work just for this demo. So if I go ahead and run the app on start by itself, it's actually frozen the screen a bit for a few seconds while it's running. And there we go. I've got a pop-up to say it took around 4.6 seconds. So again, if that was the loading of the app, it's Power Apps already takes a few seconds to load anyway. It's added about 4.6 seconds to load. Again, it could have taken a minute or half a minute. So one of the alternatives to this I'm going to show now is if I'm on this first screen, instead of do the working app on load, I'm going to click a button to go to the second screen. Again, it's going to be frozen a little bit while it's working away, and then pop up to say, hey, this took about roughly the same, 4.9 seconds. But all I've done there is make the app load faster because I'm not doing the work on app on start. I've actually moved it to this second screen when the second screen loads. So I've not made it quicker, I've just moved where the work is done. So if we look at the second screen on visible property, there, if I just zoom in, I can see again, it's kind of roughly the same kind of code that's being ran. It's just I've done it when the second screen loads. Now this is useful because it might be a screen that the user never opens, or it might be one that they only open once during the day, during their session. So again, we're kind of letting it do the slow work when it needs to be done, not at the start of the app. So this may be an alternative you could use. Now, another option here, I'm going to look at something called named formulas. So right here, I've got a screen. I'm going to click a button. Again, it's frozen the button. We can see it's working away for a few seconds and actually do some work, finish the work, and told me, again, roughly the same, about 4.7 seconds this case. It's not always bang on the same milliseconds, but it's saying that the work has been done when I've clicked the button. So again, it's not when the screen loads or when the app loads, it's when a particular feature that I want to actually go ahead and do the code and do the work. So if we look at the button on select action right here to say, well, what is it doing? What it's doing here is it's calling something called NF work. That's this part right here. And this NF work is the named formula, the NF part. This is actually doing some work and then saving it to a collection. So it's, again, it's not made it quicker. It's doing the same work. It's just moved where the work is done. And where this work is done, if I go to app on start formulas property and zoom in a bit right here on the code, again, the same kind of big sequence, silly, meaningless code, just goes through to run for a few seconds. I've shifted it to a named formula. And it's only when I call that named formula does the work get done. And the useful thing with that is globally accessible. So any screen or any place in the app can actually call that named formula. I've not had to copy and paste that same code all throughout the app. Now, related to that, we've also got something called user-defined functions. So I've got an example right here on a screen where I've got the Fahrenheit value, the temperature in a text input, and the Celsius output in a text label. So if I actually change the value dynamically, it's changing what the Celsius label value is below. So the useful thing with that, again, as I'm changing it, I'm not having to do, call lots of things to do the work on a timer. It's actually just doing it straight away by using this thing called a user-defined function. So let's take a look to see exactly what that's doing. I'm going to go to the text label to say, how is it calculating that Celsius value? This is kind of it. There's not a lot to it. So I've got a line here, this call to a user-defined function, or UDF I've used for the prefix. So there's the name of it, convert Fahrenheit to Celsius. But within there, I'm passing in one parameter, which is a text value. I've wrapped it in a value to make it a number, but it's just passing in one value. And then around it, I'm just rounding it to one decimal place so it doesn't look too crazy when we read the value. So let's have a look at where that UDF, that user-defined function is. So again, I'm going back to the app objects in the formulas property. We'll zoom in here. It's this second part, this part at the bottom. So this user-defined function, a bit like the named formula, I've got some kind of, definition of what it does. I pass in a parameter I've called F for Fahrenheit, which is a number. The output is a number, which is the Celsius. And here, this is the part that is the simple piece of PowerFX that does that calculation, just your standard conversion between the two. So again, when I've used that, I've just used it anywhere in the app because it's globally accessible. And it's just a nice way that I've been able to, kind of use that function, but again, I'm only calling it when I need it. So it's like the name formula, but we can use parameters. So it's really, really useful. So just taking a step back there, what I did in a lot of the demo as well is actually did like a notification pop-up to show how many seconds that something took. There are other ways of getting this, which we'll cover later on with monitoring and troubleshooting. But just to let you know, this is the snippet of code that I've used. It's quite straightforward. All I'm doing is getting a snapshot of the time before and after an operation happens, and then actually just using notify to display it to the screen so we can see how long something took. So just a little heads up, that's how that works. Okay, here's something that can speed things up. So we're going to get to some really useful tips now. So anyone here who has pulled data into collections from tables might be familiar with this first piece of code. We've got 4 lines there doing clear collects. So the first line is pulling from a product table into a local collection called cold product. Second line is doing the same for customer, and so on for 4 lines. Now, if we was to look at the network traffic when we run this, we're going to see something like this, where the first line runs, when it completes, then it runs the second line, and then so on and so on. So it's running them in sequence, as we'd expect. It's like a script. Do line 1, then line 2, then 3, then 4. Now, anyone who's done things like multi-threading or parallel programming, there are ways we can actually spin up multiple processes at the same time. So we can do this in PowerFX as well by using something called a concurrent function. So there I've highlighted in yellow, I've wrapped all of this in a concurrent function, and each line's got a comma at the end. What it's going to do is kick them all off at the same time. And so the network traffic will look a bit like this. All 4 things have started around the same time because they're not dependent on each other. We don't need line 1 to finish before we do line 2. We just need them all to run. So if we look at the horizontal there, if that was due to the time, let's say, for the app to load, we've done the same work. We pulled all that same data back, but we've done it much quicker because we started them all at the same time and ran them in parallel. So again, there are places this is useful, particularly when pulling lots of data or running something that takes a long time to run. So there we looked at collections. I'm just going to have a little refresh on some variable types right here. So we've got things like global variables. Right here we use the set function. Here I'm setting a pet name to Oscar. Oscar is my dog, so I'm going to use that as the example. They can be seen anywhere in the app. Context variables is another one where only in the context of that screen we can see, and this is when we use the update context function. And here I'm setting an energy level to a number of 100. And then collections, which we looked at on the last screen, it's a bit like the global variables because we can see these globally anywhere within the app. We can access them anywhere. And this is, in this example, we're pulling the accounts table from Dataverse in this case back into a collection I've called col accounts. So I'm working with a table of data. Another one I want to mention, another type of variable is a with function record. So the with function, and I wasn't using this when I started with Power Apps, I kind of learned a bit later on, but it's super, super useful. Has an example like the one at the top there. So we have the with block, then in the curly braces, we've got this record at the moment with only one field called title. We do a lookup on the user's table to bring back a value, save it, and then after that, we use it in a global variable. Now, the really useful thing with this is that they have a formula block scope. So that title in those curly braces right there is only usable within this with block. You can't use it outside of it. Because when you've actually finished with the with block, with that last semicolon that we've got, anything in those records gets cleared from memory. Now, this is really useful because if I never need to use that title field within the block ever again, or it's doing something with a collection or lots more data, it's cleared from memory instead of building up and clogging up the memory for the app. It's actually just automatically removed and cleaned out for us. Really, really useful. Also, with functions like this, they can be nested and made a bit more complex as well. So it could be very, very useful, but one worth bearing in mind. Another handy thing with these with function records as well is that they can massively improve performance if the record values are called multiple times. So in the one on the top right hand, in the top right there, the code block, we can see within this with, we're actually bringing back 3 fields this time, not just one. They're all going to the users table for the same record, and they're going to bring back title, first name, and last name. Then below that, I used them with some global variables. So nothing too exciting, nothing brilliant there. However, If I'm then refactoring this code to say, look, why am I going to the users table 3 times to look at the same record? Just go to it once and now making one data source call over the network instead of 3. So it's immediately much faster because I'm doing less work. So it's really, really useful that if you could, again, get some kind of reuse out of things, save those round trips over the network or to a different data center or to something on premises, is just to minimize those calls where we can. And the other nice benefit with these, with blocks as well, is that they can improve the readability. So right there, we can see in the top example, I'm bringing back the title, first name, last name. That's very readable. It's not some massive power effect statement that goes over multiple lines. I'm breaking things down into multiple chunks, and it's a bit more readable and maintainable as well. Really useful. So there we had some examples of using the lookup function, which we can see right here. So we're setting a global value right here, and I've got this lookup right here that goes to the users table, checks for the primary email, and brings back the entire record there. And then below that, I'm actually going to the record and bringing back the title field, but only that, and I'm not doing anything else with it. So right now, I imagine I'm bringing back a full record, lots of columns, just to get one of the column. Now, the thing with this, it's useful, but as I mentioned there in the top bit, I'm bringing back the entire record. Might be more than we need. So what we can do is we can actually use something really useful here, the lookup function called the reduction formula. The syntax there is in the top right. So again, we can call the lookup on a table, use a formula to kind of filter it, but in square brackets, which means it's optional, there is a third parameter called a reduction formula. Now this is useful if we just want a single value or a single column coming back. We don't want the full record. Because if you do that, you can refer to the columns in the table, you can just bring one back. Again, if you don't set this optional parameter, you're going to get the full record. You're not just going to get one field, you're going to get lots more. So if I was to look at that code that we had on the previous screen, again, I'm bringing back the full record for the user, and there I just get the title field. So it's doing passing a lot of data over the network. It can take a long time, particularly if it's a table like this with over 120 columns. But if I was to refactor this code, it's actually, quite straightforward. All I've done, it highlighted in yellow, is add this third optional parameter called the reduction formula. Say, I only care about the title, just bring me the title back. So there, instead of bringing back lots of fields, it brings back one. It's much quicker. So really, really useful. Now, in terms of bringing data back, we're focusing on this a bit because that can be amongst some of the slower operations that we run. So bringing back all this kind of table data, here's an example of the user table in Dataverse. I can see 3 of the columns, full name, business unit, primary email. But if we look at the end, we can see there's a lot of other hidden columns that we don't have. So again, ideally, we just want to bring back just those columns that we care about because we don't need all of them. There's a lot of that business unit. I don't often use it. I don't need it. So retrieving just the columns that we need. Here's an example where I'm bringing everything back, not ideal. So I'm bringing back everything from the users table with all of the columns, may not need it. Now the example I've got below, I've actually defined to say, look, I only care about the full name and primary email. Just give me those 2 columns. Don't give me 127 columns, yeah? Just give me 2. They're the only 2 that I want. So in this example, that's what it's doing. It's just bringing back, and in the preview, we can see we just get the full name and email because that's all we care about. So it's just a handy way of us saying what we do and we don't want coming back. Now, mentioning this, there is something in Power Apps called explicit column selection, or ECS. You might see it in documentation. This is where Power Apps tries to help us. So if you're bringing back the data to a screen and the screen only has some labels to show the full name and email, Power Apps might try and be helpful to say, oh, you only need those 2. I'll just bring those 2 back. However, there has been a rare occasion it's let me down and sometimes brought those columns back blank. I don't know if it's been fixed since or if it was just a problem with something I was working on, but sometimes I'd have to use this approach that I've shown at the bottom there with the show columns. And that was me specifying, hey, I want these 2 columns, and it will always bring those 2 back. So that one's always reliable to use that approach. So next up, we looked at the columns we don't need back. How about the rows? Again, we might look at tables with thousands of rows, but we only need 2 or 3. So here's a few options where, again, I can bring back a collection and bring everything from a table right back. That could be useful. It may or may not be what we want to do. in this table, it's bringing back everything from the users table, and it's bringing back 146 rows. However, if I was to use some kind of filter or search function, I'm actually checking here to say just filtering is the is staff value set to true, and that way I've reduced the amount of rows coming back to my gallery. So I'm not had to bring all the data back, just the set of data that I care about. As well as do this in code with things like filter and search, if you're using Dataverse, you can also use table views as well. So on the left example, again, the slower example, I'm actually looking at bringing back the full users table into the gallery. I've got all these kind of hashtag, kind of used system users and things that I actually don't really need. But if I was to look at the example there, where I've actually set on the right-hand side the gallery, I've not just set the data source, I've actually selected the view that I care about as well. This is a view that is restricting the data that comes back to only those records that I care about. So now I've only got 17 rows or records coming back, just the ones I care about. So again, it should be faster, should be quicker, because I'm only bringing back the data that I care about. And even though I'm talking about Dataverse table views here, the concept of views, whether it be in SQL Server, Oracle, even SharePoint, just to filter what we bring back and even sort it, or just the columns we care about, has been a common concept for years in other systems as well. So again, not just a Dataverse thing in this case, it could be for SQL Server and others as well. There are other cheekier ways of bringing data back to an app as well. We might not just go direct to the data source within the app. We might actually go to Power Automate Cloudflow and do this as well. So here's an example where I'm actually calling list rows on Dataverse. I've got some best practices in there, which is nice as well. I'm calling the accounts table. I'm only caring about a handful of columns. I'm doing filtering and sorting and a few other tips and tricks there, and just bring back the top 10 records. So again, even though I'm spinning that up and offloading it away from the app to bring back the data, there is a cost when we spin up a Power Automate Cloudflow because it needs to actually do some work to spin it up. The reason being is it's a separate process. It's a separate service as well, so it needs a bit of memory and a bit of time to get up and running to do the work and then return the data. But just a heads up, that's another option as well. Another option that we can do within code that could be useful as well is a caching of data. Now, cache is just a fancy word for saying that we store that data locally in the app. So this is very common when I worked in game development. Again, we don't want to go over the network every time we get data for every tiny piece of information. That's a lot of network calls, a lot of lag. Sometimes we'll store things locally and work with it in memory. So some examples of this, we might actually go to the users table and bring back the full record and hold it in a global variable. We might be bringing back just a single text value, like title in this case, using that reduction formula. Or it might be tabular data. We actually bring back one or more records and storing them in a collection. Again, if we actually call those values in the cache data instead of going over the network every time, it's going to be super fast. Yeah, it's going to be much faster because we've reduced that network call to get the data. It's almost like we're holding it. We're ready to look at it and use it right now. Super, super useful. So while it is much faster and it is a good option in a lot of cases, if you're a developer or an architect, you do want to ask yourself some of those kind of questions of, well, how often does that data change? Is it something? I used to work in retail, and we used to have like a list of stores that would kind of be the same, would only change maybe once a month or once every 2 months because we'd open up a new store or close an old store. We don't need to be refreshing that every 1 minute in the app likely. We might need a manual refresh button. Or if you need real-time data to say, I need the latest sales figures to really have that latest intelligence, that latest information to make a decision, maybe you've got no option but to go over the network and grab that latest data. So it really depends on the solution that you're building. Very brief tip here, if you're patching data for creating new records or updating them, you can patch them very fast. So on the left, it is a way that I've typically done by using a for-all loop, going through one at a time to patch records. But you can actually use something called a schema match approach, where you actually build up your collection to match what the table needs. It matches the schema, in other words. And then when you run it, it's a bit like concurrent, where it will run them all simultaneously. On the left, for all is doing them one by one, which could be fine. But on the right, it's almost always going to be faster because it triggers them all at the same time, but it's doing the same work. So some good blog articles out there online, Matt Devaney and many others have got good walkthroughs on how to do this. I'd highly recommend checking it out. And some other brief tips and tricks, particularly in this code side of things as well, that I just really want to briefly mention. Things like over-engineering, you kind of know it when you see it, or when you do it, it kind of might feel a bit off. So things like cross-screen dependencies, calling variables and controls from other screens, actually loads the other screen into memory. So it's kind of doing a lot of work behind the scenes. It's best just to navigate between screens and pass those values as you need them, or use global variables if you can. Things like nesting galleries and others, you can do it. It looks cool, it looks clever, but it can go really clunky and slow because they're not really optimized to work that way. Things like galleries, you can get the counter records in them quite easily with properties. Do you need screen transitions? I found on some slow devices and slow networks, different parts of the world, different structures that people are working in. Sometimes those fade transitions and others might go a bit jittery and a bit slow, and it can kind of look a bit bad. So maybe using the default with none can be a good way to go. Use of timers as well can be a bit slow and cause issues within Power Apps, I've noticed. Things like data refreshers, you might have it polling every minute, for example. If you need any kind of offline features in Power Apps, there's a really good native feature right now, as that's been around for a little while and generally available. So worth bearing in mind, rather than doing a code-based approach with your own syncing, you can actually look at those mobile offline profiles. Very, very useful. And things like publishing your app regularly, even if you don't change any of the code. Sounds silly, right? But because the Power Apps engine is getting updated all the time with new security and performance improvements, even something as simple as opening it and hitting publish, you're going to get the benefit of those new updates that Microsoft product teams have created. So yeah, really worth doing that, even as a monthly task, for example. So we've covered a lot. That's one of the big sections, but next up, we're going to look at some architectural optimization. So these are not big architecture questions necessarily. These are just standing back and taking a different look at things. So things like within Canvas apps, you can upload media, things like images, audio, and video files. That way, a bit like the caching we talked about before, they're on hand to be used. We've not had to go over the network to retrieve that data. It's just ready to be used. If you are using that for images, I would recommend that SVGs, scalable vector graphics, if you can get them, are really, really good because they're typically much lighter than things like PNGs or JPEGs. And also they scale well when you increase the size. So really worth looking into. If you're using Dataverse tables and using image columns, you can use the image thumbnails, which is like an auto-created thumbnail sized image created by Dataverse in things like galleries, where you just need a small little preview of what it is. Now, this is really good. Otherwise, the full size, the full kind of file size of those full-blown images are going to be brought across as well, and it might cause some lag and go a bit slow. But these image thumbnails, it's a URL that gets generated automatically by Dataverse, could be useful depending on what you need. If you have any elements within Canvas apps that you don't need anymore, so I'm thinking of like data that you don't need, we've got a handy button to remove those. You don't need to go through and manually check. You just click it and they actually just get cleared out for us. Same with the media that we just talked about. That's been around for a while, and also with flows as well. So I'd highly recommend using these because I've done this before. I've created apps, added 10 data sources. By the time I finished dev, I've only got 5 of them in use, but the other 5 are hanging there. It may or may not add some lag to the app, but it's more memory that the app needs. So the short version is, if you don't need it in the app, bin it, because it's likely going to take memory and impact the performance in some kind of way. So yeah, it's good to house clean where we can. Okay, so let's have a look at the app checker. Now, the app checker is a really handy thing. If we go in the top right and look at this stethoscope right here highlighted, it's a way of actually giving us a few warnings and any errors that we've got with performance and other parts of the app, like accessibility, formulas, runtime, and so on. So we're looking at performance today. So let's have a look at the performance. We've got 11 warnings in this example. We can see there's some unused variables. We'll zoom in a bit there so it's easier to read. We've got things like retrieving data from source. Maybe there's some issues and warnings around those as well. So this is a handy way to give us, a little heads up there's a problem. So if I actually drill down to one example there, I can see there's an unused variable. That's the issue. Variable's not used anywhere. It's detected that. Here's where to find it. There's the location, how to fix it, get rid of it, is the short version, and why we'd want to fix it as well. So again, if it's not being used, it's likely going to need some memory and it may impact performance. So let's get rid of it. Let's clear it out. So as well as that unused variable, we can see there's some other things here as well, things like data row limits, the rows retrieved. Again, by clicking on these and looking into the detail, we're going to get a bit more information about them. So yeah, really worth looking into. Next up is a tool that it's not been updated for a little while, but it still does hold some value, is the Power Apps Code Review tool. Now, this is something created by the Microsoft Power CAT team. CAT is a customer advisory team, CAT, and they create different development tools and things that help us along the way. Some are still in preview, some like this are ready to use. So what this does is it reviews a Canvas app, you point it to the app you need, and it goes through a checklist of best practices. It gives us a score, so for example, an app's looking really good, it gets a 90%, and it scores like an exam paper, it gets an A or a B or something like that. So the app checker results that we just looked at, they're actually brought through into the this code review tool as well, so we can see them there. It does some app analysis. It checks things like the setting flags we've got there, if you've got too many controls on the screen, and so on. And also there's a code viewer where you can list all the screens, controls, and easily just scan through the code, and it points out why things might be an issue and how we can improve them as well. So really worth looking into. It's free, it's good to use, and some good walkthroughs and blog articles on how to use it as well. Another thing about being an architect, sometimes we take a step back and say, sometimes things have become a monolith. A monolith might be a term that's used to say something's it's grown too big, it's got bolted onto, got extended, and it's become a monster. It's become doing too many things, and now it's going slow, it's creaking under the weight, it takes too long to load, for example. So really what we'd want to do in many cases with monoliths is split them into smaller things, let's say smaller apps or smaller services. So the concept really being in development is that we'd rather have a smaller thing that does one thing really, really well instead of one big thing that does too much. So for example, anyone who's familiar with Dynamics, we have, we might have sales, we might have a CRM, we might have field service. We don't have just one dynamic system that does 20 different things and it just crawls really slowly because it does too much. It's doing separate things. So if we do want to do that with Power Apps, we can, but we can still have a seamless thing where it's not, the user doesn't have to open 5 apps and then navigate in each app to the same record. We might be able to open one app, then use the launch function to open up another Power App and pass in some context variables as well to say, well, I notice you've got this contact record with this ID open. So when you click and open this other app, pass that across and open up that app for that contact record. So again, we can provide a seamless experience without expecting users to open, I don't know, have like 5 different bookmarks and open apps and kind of do the hard work. We can make a good user experience for them. So you probably noticed a lot of this focus has been on Canvas apps because Canvas apps are by their nature very customizable. We can make them bespoke, which means we can make good decisions for performance, and we can make bad decisions for performance as well. The great thing with model driven is a lot of this is handled for us already, and a lot of it is very performant and scalable already, which is really, really good. So there still are some things to bear in mind, such as the default tab controls that when we open the app, all that initialization logic is invoked on load. So if you've got a busy screen and it's doing lots of work, it may contribute to how long it takes the screen to load and be ready for the user. If you're using any data-driven controls, in other words, controls that might need to go to other tables for data or summarize data or join to others or aggregate the data like Summit and do things like that. Things like quick view forms or subgrids or timelines, they're going to go elsewhere to pull that data in. They may need some extra time to perform those data queries to bring the data. So again, just something to bear in mind. If it's busy with them, it might be busy in terms of performance as well. And things like JavaScript, now we're getting into a bit of pro code here. We can make good and bad decisions with any kind of code. You might have busy loops. There might be things that are run synchronously. There are ways we can actually, maybe use tools like Copilot and others to help optimize that code and use some good practices to make it performant. Also, us as makers or developers, we've got our own optimization and many tools like, I mentioned Copilot, and there's also ChatGPT or GitHub Copilot. There might be tools we can use to actually speed up our development ourselves as well. So a good concept there, or dry or don't repeat yourself. So this is really all about considering reusable items. So we're not actually reinventing the wheel on each screen or in each app. So things like named formulas that we covered and the user-defined functions, they could be used anywhere within the same app. Super useful. You might have things like components, where I've got an app with 5 screens, and each screen I want the same header. I need it the same look and feel to do the same thing, but I might just change the title piece of text in the middle. So there I can use components that I can actually use on multiple screens. And I change it once in the component, gets reflected on all screens. Similar concept as if we want those components to be used across multiple apps, we could use a component library. So those headers and menus and footers, they're used in the next 5, 10 apps, or however many I build. That way for users, they've got the same look and feel, and they're not having to go through training to understand how to use it each time. Also, there's the concept of Dataverse functions. These were known as low-code plugins a while ago. These are going to be useful when they become generally available. They're still preview, last time I checked, but these are a way that we could write a snippet of Power Effects and actually reuse it throughout the Power Platform. You might be able to use it in a Power Automate flow. You might be able to use it in a Power App itself. So again, we're going to get reused like outside of apps now, in terms of other parts of the system. So something to keep an eye on. So one thing I want to mention as well, I come from a pro development background. I am sort of very, I don't know. The training I've had is on concepts like normalization, where if I looked at some kind of data model, now this is zoomed out, it's not intended to be readable, by the way, but something where, every piece of data got its own entity. All those lines mean that those tables are related, one to many here, many to many there. It's kind of, really intricate, big spider's web of a data model. However, when I started to use that with Canvas apps, I realized that all of the data queries behind the scenes that I couldn't control were actually being done, and it was going very, very slow to look up all this data. It's doing too much work. I've made it in a clunky way. So I learned the hard way that what I needed to do, again, this is zoomed out a bit, is actually go for a more simplified data model. Sometimes I might repeat the data or keep more data in one table and instead of split it into 4 or 5 tables. And that typically works much more performantly. So for me, there's a bit of trial and error, but something to bear in mind with Dataverse. Also, some simple questions about where are your users based? So as mentioned at the start, I'm based in the UK. I might be working for a customer and they might be based in South Africa. They might be based in Australia or Canada. So really, in those cases, I want to bear in mind where the users are based, not where I'm based as the developer. So if I'm spinning up a new Power Platform environment, I might choose the region that works best for my customers because they'll get the best performance. This could be the same as if I've got any on-premises local networks. The customer might be in Canada, they might have their own local network. I've got to bear in mind that they've got to, communicate with that local data themselves. So for me, it might go really slow as the developer, but for them, it needs to be fast for them because they're the end users. It may also be that you've got services in the cloud as well, maybe in Azure or in AWS or elsewhere. And it may be that you decide that when you spin up those resource groups in Azure or elsewhere, you decide exactly what regions you choose. And those regions are really the physical data centers where that data is stored. So again, if I was to choose one and chose UK South or UK West, I know they're going to be based in this country for me. They're going to be based here and have a good performance for people accessing it who are UK based. So just to carry on just for a little longer before we get to the Q&A section, just a few more slides. We're going to look at, in terms of Canvas app data sources, we've got a few options what we can pick. So out of these, just have a think to yourself what might be the fastest. We're going to look at an online data source such as Azure SQL, something that is on-prem on our local network, such as SQL Server on premises, and then Dataverse, which is part of the Power Platform, of course, itself. So again, out of these 3 options, let's take a quick look at all 3. Now, the first one, the online data source, let's say Azure SQL database, could be a good choice if you're scaling up enterprise scale and you need millions of rows or lots of tables in a big data model. It doesn't always have to be Dataverse, of course. What we do is when we're at the Canvas app on the left on this diagram, this kind of techie diagram, is we need to go through two layers, API management and the connector, to get to the data source on the request going out. And then the response needs to go through the two layers to come back to the client app. So again, doesn't mean it will always go really slow, but it's adding some latency to get that data. Now, the second one there, the on-premises data source, again, on your local network, it's actually got another layer. It's got three layers because we go through API management, or APIM, sometimes known, and the connector. But then we need to go through a data gateway to translate that cloud to local network traffic and all the security with it as well. So with that, we've actually got three layers to make the request and the response. So again, it's going to add a bit more delay to getting the data. However, if we choose Dataverse, we've got a direct connection to Dataverse because it's part of the Power Platform. So the really cool thing with this is it's the fastest connection to any data source that we could have with a Canvas app. So that should mean that it's the winner, right? Now, while it is the fastest connection to get to the data, there's so much out there that depends on what are we doing with that data. How do we filter it before we return it to the app? So you might be doing something in SQL Server, like using a view or a function or some other way where we've kind of optimized how we deal with the data before we return it. So even though we can get to Dataverse the quickest, there's also what are we doing with the data and how fast can we transform it before we respond with that data. So again, this depends on the solution, depends what's already in use. So a couple of things I'll briefly cover just to wrap this section up here is implementing delegation. That's just in terms of how do we bring that data back. The short refresher on what delegation is where the PowerFX query in the Canvas app, we're delegating the workload to the big, powerful, strong data source. So I would say it's like we're delegating the work. Otherwise, if we can't do that, all of that data gets returned to the app, and then it gets filtered and sorted and anything else that we do with it. So we really want to deal with delegation where we can. So again, only the results come back, so it's more performant. So we can do this in Dataverse, but other data sources like SharePoint, SQL Server, and Salesforce as well. And on the table on the right-hand side, this is delegation for Dataverse specifically. We can look there, the green highlight is saying if we're doing an equals check on a text column, it does get delegated to Dataverse, so it gets dealt with there. And if we do something like a search on a number, it doesn't. It has to bring all the data back and then do the search within the app. So it's bringing more data back and it's doing work in the app to do that kind of search. So it's worth bearing in mind when we see delegation warnings with a little squiggle on the code in the app, they're worth paying attention to. Particularly because with Canvas apps, we're kind of limited to just the first 2,000 records. So if you're pulling from a table that has got more than that, we're going to struggle. It might actually truncate and lose some of that data when it returns it as well. So I'll very briefly, just in the interest of getting to Q&A, fly through a couple of slides for user experience. So we can have busy UIs. There are some, standards out there to say, look, can we just have 300 or less controls per screen? Because any controls need memory. So the more we've got, the more memory it needs. Anything repeating, we can use galleries. And you can always split screens up into different tabs and sections if we need to, so they're not as busy. There are things as well, I won't go through the demo just now, but we can use things like progress bars just to give that feedback to users if it's going to take a few seconds, just to let them know, hey, the app is working on this. And then we can use things like delay output in the text import control to actually say, do we want an instant response to this query as we're typing in the search box? Or do we want to wait for the user to finish typing and then perform that data query? And if we do need to do any monitoring and troubleshooting, we've got things like the Power Apps Monitor. Again, it's near the app checker. It's just on the right-hand side. We can get to that and actually hook into a session to get more information for what it's doing. You can use trace functions as well in the PowerFX to report some of this information to things like Power Apps Monitor and App Insights with a syntax a bit like this example. And again, it will show it there when we use the monitor. So really, really useful. Just say, well, why is this bit going slow? And if we needed to, probably not. But this is a bit of a pro dev thing. We could actually look into the browser, the web browser's development tools, and just look into that deeper information. I've never needed this for Power Apps, but I just wanted to mention it in passing anyway. So with that, I'll just wrap up. What we covered today was code optimization, some architectural optimization, some UX considerations, and briefly the monitoring and troubleshooting as well. So with that, I'll pass back to the host. Thank you very much for your time today. I know we covered a lot. There's a lot of information. So if there's any information, just feel free to connect with me on LinkedIn there. Always happy to help others if you've got any questions. So please do. So thank you so much.
Thank you so much, Keith. That was great. Oh, as a marketing person, I was a little bit lost, but I hope that it was valuable for those who do understand what's going on. I'm just going to open the floor up to anybody who may have a question while we still have Keith with us in the webinar. Any questions?
Yeah, feel free to raise the hand in Teams. I'll go through one at a time. And if there's not, again, always reach out to me afterwards on LinkedIn. Happy to help. Hi there, Chad.
Oh, I was looking at that with statement. So that is similar to a using statement in C sharp. Well, when you dispose objects, if I'm correct.
Yeah, exactly right. So anyone who's familiar with C Sharp, if you use a using statement, it automatically does that garbage collection and memory management after it's done. So we don't need to then dispose of the objects afterwards. So yeah, if you come from that background, that's exactly the way to see it. Very useful.
She always wondered how do you do that in Power Apps. Gotta go.
Yeah, that's the
Excellent.
thing. Yeah,
Something
I
else.
wish it's a great question. Thanks for that. I wish I'd known sooner because I never used to use it, and I don't think it caused too many issues, but I knew the memory was building up and never getting cleared. So some people would build up a collection and then clear the collection afterwards, and it just felt clunky to me. But yeah, if you use the with block, it kind of just auto disposes of it. So yeah, great question.
And the other one was the lookup statement. That looks like lambda to me. It looks similar to a lambda expression.
Yeah, again, yeah, very, very similar to C sharp and the lambda statement. So yeah, just for context there, yeah, with the lookup statement. In fact, let's see if I can just jump to that very quickly. But yeah, this is a great way where again, we're the ones who are specifying. Let's just go through these really quickly. Yeah, there's a way of saying, that's going to take too long, but yeah, there's a way of saying, hey, these are just the values that I care about. You could even do a bit of a formula on it as well to say, I want it this plus this equals this. So there's a way of just bringing back just what you need. But yeah, exactly right, just like a lambda function.
Thank you very much.
You got it. I've covered so many things. Look, how
Yeah,
many
no,
things
that's
to go through,
actually.
right? There we go. This is the slide we're talking. So the reduction formula is like the lambda function that Chad mentioned there. Hi there, Dwayne. Yeah, go for it when you're ready, Dwayne.
He's muted.
Dwayne?
No worries. Yeah, it's not coming through, but if we don't catch it now, just again, feel free to hit me up on LinkedIn.
Great. Anybody else have a question before we wrap up our session?
Cool. I think we might be done.
All right, awesome. Thank you so much. Oh, Chad. Go.
Yeah, straight in there.
I
Go,
just
Chad.
wanted to know how is the memory handled on a Power App? Is it in the browser specific?
Oh, I'm sorry, I missed that. Sorry, Chad.
Is the yeah, how is the memory handled? Is it handled in the browser or is it handled on Microsoft side on the Power Platform itself?
Yeah, great question. Thank you. Yeah, it's one of those where it's kind of a bit of both. I mean, the Power Apps engine deals with it, but really what it's doing is the Power Apps engine is really a web app that brings it into the browser. So yeah, luckily the web browser tools can help us there. We can actually go through and peek at the code and see what it's doing. And we can look at the memory management of heaps and nodes and get to that level if we really needed to. But yeah, that's another reason where when we have something like a delegation, we can actually see, whoa, there's too much data being brought back to the app, and that's where the heavy lifting's being done. So yeah, using things like the browser tools, we can see it is really being brought back to the browser, and we try and reduce that as much as where we can.
Thank you.
Yeah, great question. Thanks for that. Oh,
Dwayne
great.
has posted his question in the chat. I'm happy to read it out. Which of these optimizations are most commonly missed by teams in real projects?
Yeah, thanks for reading that out, and thanks, Dwayne, for the question. It's a really good one because I know from my personal experience, things like this screen now, the reduction formula came to me a little late. It was almost like all the blogs and articles I read when I was self-taught with Power Apps, not many covered this. So I didn't go to all the Microsoft Learn documentation, and I wasn't even aware of it. I was copying patterns I saw other people create. They'd missed it, meant I missed it too. So for me, this was one that came late to me in the day. The with function came late to me in the day, like we mentioned there, like almost like a Lambda function, because again, I didn't see many examples out there, or it wasn't covered by the basics when I was learning Power Apps. And I think one of the big ones, the third one I mentioned, is probably the concurrent formula. One of the first things that I mentioned there. So by using that concurrent function, again, anyone who's familiar with multi-threading or parallel programming in ProDev world, where you spin up multiple things at the same time, and then they all finish quicker because they've all started at the same time, is great around like big data pools and things like that, where I've met some developers who've not heard of it and just thought every line has to be done in sequence one by one. So yeah, I'd say this lookup reduction formula, the with formula, and then the concurrent formula, probably the big three that I noticed time and time again. Loving the questions, by the way, great questions. Thanks for these. I can tell you're paying attention because they're all really good. Okay, I think we might be done, Bottomella.
All right, awesome. Thank you so much, Keith. Thank you, everybody, for joining us at the end of your workday. Hopefully, you're not stuck in traffic. But please do join us for our next webinar. But yeah, thank you so much, everyone, for coming. And a big, big thank you to Keith. We really appreciate it. Hopefully, you're not jet lagged.
All good this time. Yeah, thank you. And thanks so much for having me on. It's been a lot of fun. Thanks, everyone, for joining. You got it. Thanks. Bye, everyone. Take care.
Thanks, guys. Cheers.
Thanks.
Bye.
Thanks, guys.
Bye.